Use substitution to solve the system of equations. So notice that this one doesn't have a variable by itself. So we have to first take one of our equations and get the variable by itself. We're going to use the second equation because x has a coefficient of 1. So we don't have to worry about a whole bunch of extra work. We simply take 4y and subtract it from both sides. And that gives us x equals 18 minus 4y. Next, we take the 18 minus 4y and we substitute it for x into our first equation. So this becomes, instead of 5x minus 3y equals negative 25, 5 times the quantity 18 minus 4y minus 3y equals negative 25. Remember that the whole thing, the 18 minus 4y, is our x. So we have to have those parentheses to distinguish that. Then we use the distributive property and we distribute the 5 to everything inside of our parentheses. So 5 times 18, which is 90, and 5 times negative 4y, which is negative 20y. Combine like terms, so minus 20y minus 3y gets combined. So we have 90 minus 23y. And then we're going to subtract 90 from both sides. So we're going to have negative 25 minus 90. And I don't know what my negative 25 off the top of my head minus 90 is, so I'm going to use my calculator, and I get, I need to go back to my mouse here. We get negative 115. So y equals 5 after we divide by negative 23. Now we have one of our variables solved for, so we're going to plug that back into one of our original equations, and it doesn't matter which equation you use. I personally always use the one with the smallest numbers because it makes it way easier to do the math, and the computer also used that same method. So we're using the second equation, the x plus 4y equals 18, and we're going to put the 5 in for y. So 4 times 5 is 20, so x plus 20 equals 18. Subtract 20 from both sides, and we get negative 2, because 18 minus 20 is negative 2. And that means that we have our intersection, where the two graphs intercept, at the point negative 2, 5. Right? And remember, the x always goes first. It's always x, then y. Would the solution of the system be the same if the first step used was to solve the second equation for y? Explain your answer. Make sure you put this down into your notes because it will come up later on our Canvas page. And a quick study tip for you. If both equations are in the form y equals mx plus b, slope-intercept form, the expressions can simply be set equal to each other rather than solved for x. For example, if you have the system y equals 2x minus 5 and y equals negative 4x plus 1, then you can rewrite it as 2x minus 5 equals negative 4x plus 1. Then a solution for x can then be used to find the value of y. You put that into either one of those equations. It doesn't matter which one. So I'm going to go ahead and I'm going to show you what that looks like. So we have 2x minus 5 equals negative 4x plus 1. I'm going to add 5 to both sides. That gives me 2x equals negative 4 plus 6, x plus 6. I'm going to add 4x to both sides. And that gives me 6x equals 6. When I divide by 6, that gives me x equals 1. Now I take x equals 1 and I put that into either one of the first two equations. I can put it into 2x minus 5, or I can put it into negative 4x plus 1. Personally, I don't like working with negatives, so I'm going to put it into the first equation. So 2x minus 5 equals y, and I'm going to put that 1 in for x. So it becomes 2 times 1 minus 5 equals y. 2 times 1 is 2, and 2 minus 5 is negative 3. So that means I have a solution at the point 1, comma, negative 3.